Yes. Okay. You're most welcome to our platform over here. My name is David, and I welcome you all to this platform. Yeah. I come here representing the Science Theatre, Uganda, and I am the leading man, the CEO of the Science Theatre. I'm the director. I've come today. Yeah, we have a couple of teachers. We're going to be seeing them coming to teach you. You just subscribe for more videos. Once you subscribe, you get more videos, you get more information from us. It is about science. And you know that math and logic from the left hemisphere of the cerebrum. So we're going to talk about science only. Today we have brought metabolism of purines. Yeah, we have compounds called the purines. These purines okay, those following us online, we shall continue. Yeah, we shall continue. We have COVID which came here, but we shall continue. We are going to talk about purines today, and I'm happy you are there watching us. Don't forget to subscribe. Yeah, I'm going to discuss basically. Let me try to give you the objective. It is going to be several videos, but this one is opening video for many which are to come. For instance, when we talk about purines, yes, we shall talk about the bases, how they look like. We shall talk about the function. Here I'm going to basically talk about the functions of nucleotides. I won't specify purines alone. We shall talk about the metabolism, which metabolism has anabolism and also has catabolism, which we can call degradation, right? And we can talk about some drugs, and we can also talk about deficiencies, and we can also talk about deficient diseases or syndromes, and we shall also talk about basically this, and more will be coming in slowly. There are some experiments which you can talk about. Which experiment might be based on antibody monoclonal, antibody selection. Basically, that will be the aim of our discussion. But today I want us to talk about, I'm going to introduce the nucleotides and go directly to the purines only. Okay, just follow, just subscribe, always. Subscribe, always. Subscribe, always. Okay, thank you. Let me rub off a restart. Yeah. So if you are to talk about something called nucleotides, nucleotides is the components which make up the nucleic acids. And nucleic acids, I'm talking about the ribonucleic acid or RNA and the deoxyribonucleic acid. A nucleotide has a basic structure or a uniform structure, which will be having a nitrogenous base. Yes, it will be having a ribose or a pentose sugar. And this is just a base, nitrogenous base, a pentose sugar, and a phosphate group. Those ones make up what you call a nucleotide. Yes? A phosphate group can be 1, or can be 2 or 3 basically. That is it. And this phosphate group, yes, that is it. That is when it is here, this is called the nitrogen base. When it is here, we call it a nucleoside. Yeah. When it has all the 3, then it becomes a nucleotide. Yes. So we have a nitrogenous base, a nucleoside, and a nucleotide. For example, if the base is adenine, the nucleoside will be adenoside, and the nucleotide will be adenylate. Adenylate, or what you can call adenine monophosphate. If it is only adenosine monophosphate, if it is only a nucleo, if it is only one phosphate group. So that is the structure of nucleotides. Can be pyrimidines, yeah. And in our nucleotides, we have purines and pyrimidines. Yes, the purines we have. These are not nucleotides, but we have nucleotides which are made from purines, and we have nucleotides which are made from pyrimidines. You get it? So these are nitrogen bases. So these two are nitrogen bases. So the nitrogen bases we have, the bases you can talk about these ones. These nucleotides will be made from adenine, and will be made from guanine. Yes, the pyrimidines will be made from cytosine, uracil, and thymine. Yes, that is the introduction of nucleotides I can talk about. Yes, let's continue. Yes, to add on to that, I want to go into the structure, and you see, a nucleotide, for example, the purines, the structure will be having a 6-carbon ring made up of nitrogen and carbons, and we shall be having an imidazole ring. So that is the basic structure of a purine. Yes, so this is just a purine. Yeah. Then you can make sure you observe these H hydrogen atoms here. We can also have another. Yeah, it is only there. So, and the numbering of the purine, we shall call this one the first. This one the first nitrogen, carbon 2, N3, carbon 4. Yes. This is 5. This is 6. This is 7. This is 8. This is 9. So you see, you have the hydrogen atom at carbon 9. So this one is unclockwise, whereas this one is clockwise from 7. Yeah. Then we have what you can call the purines examples we talked about adenine, which adenine will be having something like this. N there, something like that. Yeah. So adenine, how does it look like? We'll be having amino group at carbon 6, like that. It means this one will be like that. Here we shall have H and an H here. You get it? Yeah, that is adenine. Then if we talk about another example of a purine, and that is called guanine. Yes, guanine What is the difference? I want us to talk about guanine. And if I can add on some names. Okay, let me first draw the structure. So guanine, this is carbon. Here we shall be having oxygen, and the amino group will be at carbon 2. So it means if this is my purine, like that, it also has a midazole ring, like that. It means in the guanine we shall be having an oxygen atom there and amino group at this point. So this carbon will be there. When you look at this, this carbon will also be there, and this one will be having hydrogen atom. So look at it closely and understand how it looks like. You get it? So if I can add on some names, yeah, the names, this one will be called, this one will be called 2-amino 6-oxopurine. Whereas this one will be called 2-amino. This one is just the 6. Because this is carbon number 6. 6-amino purine. Yes, that is what we can talk about the purines, how they look like. They have carbons. So this will be important in the synthesis, because if you know the structure, we shall be moving smoothly in relation to synthesis of these compounds. So let's talk about the pyrimids and then the rubber. Maybe I can talk about I've brought the duster, but before that, when you look at adenine, there is an unusual base which I can't forget to talk about. Unusual base. You know, when you need to prevent these bases from being degraded by enzymes, or to be incorporated into some, or to be cleaved by some enzymes, you must add a certain group, a different group to the base. So this one can get dimethyl. Look at this. You can have adenine like this, and that is my adenine, like that. Adenine had an H there. It was like this, yeah. So this N can receive a methyl group and a methyl group, like that. So when you put two methyl groups to adenine, you form an unusual base, and that will prevent the base from degradation by certain enzymes, or allow it to be degraded by certain enzymes. The unusual bases are usually found in, you can talk about in the tRNA, transfer RNA, and you can also talk about the viral DNA. That's where you find unusual bases. Yeah, let me wrap up. So, now to add on, let's talk about the purines. Yes? So, the pyrimidines. Those have been the purines. So, So now what about the pyrimidines? Pyrimidines also